I'm Chuck Wisman from Megger. I'm going to demonstrate the HT1000 in bringing up a triple play circuit with video, voice, and data. So first we're going to check that we have a non-working circuit here. So I'm going to go to volts. See, there's basically no voltage on it. If there was a live circuit, this would be typically 52 volts, but I'm going to go with tip ground, ring ground, and basically no volts. And there's no crosses either. If there was a cross with another pair, there would be some residual DC voltage there. Next step is leakage. We'll be measuring the resistance or leakage between tip ground or tip ring. There's tip ground and ring ground. And it's drifting some because the capacitance charging up. But notice that tip ground and ring ground are both over 30 megs, so that's acceptable. The tip ring is a bit lower than we'd want at 3.5 megs, but it's still acceptable. We're going to go to resistance. It's a bit of a repeat in that we already know that we've got very high resistance already. We'd go to the resistance circuit if, let's say, we were looking for loop resistance. It's more used for lower resistance values. But we basically get the same values that we had when we were looking at leakage. Over 30 meg on the tip ground and 30 meg on the ring ground. Okay? Right, okay. Now we got to number 5. That's the stress test, super stress. Typically, for this circuit, we'll want under 30 dB. Some telephone companies also use 20. In this case, we're below 20, so we've got a good stress test. Alright, so we want to check the length of the line, so I'm going to use the open meter for that. So we've got about 870 feet tip to ring. 850 tip to ground, and about 850 ring to ground. The most important readings are these two, that they're about the same, and they're both about 850 feet. In addition, we want to verify that that's the length of the line that we're looking for, and it is in this case. Okay, we're also going to be checking for load coils. That's number 8. We'll start the frequency sweep. You can hear it, maybe you can hear the speaker, you can hear the frequency sweep, but so no load coils, that's good. Okay. Now we'll go to 0, that's the TDR. We'll do two things here. We'll be checking for bridge taps, and we'll also be verifying the length that we got with the open meter. So keep scrolling out. There's an event there. It's a minor event. It's probably a splice. More cable. More cable. Okay, there we are at. And the TDR is saying about 846 feet, which is pretty close to what the open meter said. In addition, there really are no events between the launch pulse and the return. So there are some, if there was a bridge tap there, there'd be a much more pronounced waveform. All we have here is this kind of a minor event at 850 feet, and that's a splice. Okay? Alright, now we're going to go to the wideband noise or the spectrum analyzer. That's the asterisk key. So what we're looking here in the general guidelines is for a very good line we want to be below -60 dBm, and we're just about there. Notice the signature, that's essentially a VDSL profile signature, and we're getting that from crosstalk from the other pairs that are in the circuit. Because it's down below or about -60 dBm, it's not a concern. So we've got a pretty good, clean line as far as noise-wise. Now we're going to be going to the second menu. I go that with the hash key, the pound key, and then we're going to push number 5 for impulse noise. This is looking for spikes that come from dirty power that the spectrum analyzer may not catch. It's more of a transient event. So depending on what the telephone company's guidelines are, you would stay on this line for a period of time, maybe 5 minutes, and look for any hits. We won't stay here for 5 minutes, but the time that we're here, we're not seeing any hits at our threshold, which is now set to minus 35 dBm with a filter, a G filter. And then we also display hits below our threshold and hits above our threshold, and we're not getting anything. So again, it's a clean line.